Welcome, welcome, welcome. Thank you for joining us. Dr. Jon here for Extract Talks. How are you guys doing? I got Stefan Egan here.
How's it going?
Extraordinaire.
On occasion. On occasion.
It's more than just an occasion.
I appreciate it.
Six Sigma we got here, who's sitting across from me.
Yeah.
We're going to kind of continue our discussion on water soluble.
Yes.
I think we're going to go into a little bit. We kind of were talking offline and we kind of got into this big, long, discursive discussion. So I thought, well, maybe we'll do another podcast just on this particular topic. And really what we were discussing was comparison of a liposome to an inclusion complex.
Right.
We'll kind of go through basically what a liposome is first. I'll tell you what an inclusion complex is, and then we can kind of talk about process, then maybe benefits and negatives associated with each of those.
Okay.
Yeah, so why don't you go first? I mean, you are the liposome master, so.
Don't put that on me.
Oh, you are. That's it. Own it. Own it.
The process that I've been using is liposomal based, right? We're taking lipids and long-chain triglycerides, making an emulsifying agent out of those, right? So that could be anything from Kwajalein extract to gum Arabic or Arabic gum.
Lecithins of all kinds, yeah.
Absolute soy or sunflower.
Phospholipids,
Yes,
yeah.
Exactly. And then we are blending our target molecules or cannabinoids into them, right? And then emulsifying them with a sonicator. So we're hitting it with high
energy, high shear energy,
high shear
basically.
energy, yep.
Yeah.
And it's increasingly higher shear, right? So we'll start at...
Oh, you have to start really low and then you go
low.
high?
Correct,
oh, okay.
right? And the whole point is to slowly break down the molecules or the compounds so they can blend together instead of just hitting it at a very, very high frequency right away. So it's a gradual process to get, even breakdown across the board.
How do they do that with like a flow through? I've seen these flow through ones, or are they recirculating and then hitting it again and again and again with a higher? So they still have a sweep, I guess, of frequencies otherwise, but it's a recirculating loop. Okay.
Yep. And then after the recirculation loop, it goes through the filter, and then it's a finished product or ready to be added to your finished good. I prefer the batch process over those, honestly.
Okay.
I feel like I can get more done faster.
And you mean better than the recirculating side?
Absolutely.
Okay. So that's liposomes, and liposomes they're encapsulated microparticles or nanoparticles, like we had discussed on our last podcast, is very high degree of particle size variability. You could filter.
Yep, and that's typically what you do in the process. You filter out.
You 0.2 0.2.
0.2.
Okay,
exactly.
all right.
And that kind of removes out whatever particulates still
Some
there.
larger stuff. And okay, I wonder if there's such a thing as nanofiltration. You could nanofilter your way through, to smaller particles. Yeah,
absolutely.
I suppose.
But I think you would lose potency going that route.
Yeah, you mean the yield of the process would be a lot lower. Then you'd have variable amounts of bioavailability due to the changes in the particle size, right? So, so that maybe in a pharma process, you'd have much more well-defined particle size distribution, whereas in consumer, probably a little less less important.
If your emulsion goes into the liquid,
it's water soluble.
It's water soluble.
Okay, there you go. No other requirements.
No other requirements.
A lot of pharmaceutical companies have been using, self-emulsified systems. They've been using those in addition to like liposomes, and there's a whole body of literature on that. If you guys want to get into that, maybe we'll do a podcast on that sometime in the future.
Excellent.
A lot of those said systems, you can buy them from a company and then, try them out, test out the solubility. So those are really good. And they're self-emulsifying systems, which are really great. But that's not an inclusion complex. Inclusion complexes are typically cyclodextrins. There's alpha, beta, and gamma cyclodextrins, and those are sugars. And they're cyclized sugars. They make little circles, and on the inside of the circle is hydrophobic, I guess, and the outside of the circle is hydrophilic. In the right conditions, you can have the hydrophobic material, small materials, be encapsulated in this inclusion. The way you typically would do that is you'd buy the cyclodextrin from a company that we know, and they have it specifically modified so that it will actually use them in CO2.
Right.
You put the stuff in the CO2, you put the oil in the CO2, you put them together, the molecule goes inside of the inclusion, and then you can release the CO2 and you have this inclusion complex.
Ready to go.
Ready to go with no water,
filtration,
no filtration.
That's amazing.
And the particle size is pretty uniform as long as the cyclodextrin that you're starting off with is also uniform, because that's the main particle size.
Right.
Just for you geeks out there, you're talking about 6 to 7 angstroms in diameter on the inside of that, like an alpha cyclodextrin. The beta is, I think it's a couple extra angstroms. Angstrom is 10 to the minus 10 meters. So
super small.
Yeah, super small.
Super
so
small.
You got nanometer, that's 10 to the minus 9, and 1 angstrom is 10 to the minus 10. So it's really small.
Yeah, that's super tiny.
Suffice it to say that you could stick stuff inside of that cyclodextrin. You could do it in CO2,
right?
And it maintains its particle diameter pretty nicely. You also get agglomerations of particles. Just like in liposomes, it'd be the same thing where you get multiple cyclodextrins that are kind of stuck together.
Right.
So I think that you can also filter, I suppose, because you're going to get those agglomerations. Right. Yeah, so you can see there's obvious process differences, right?
Tremendous process differences. I mean, right out the gate, we're not using any type of water,
right?
Which is significant in the process portion, because water can grow culture over time.
Yeah.
And if your water's not really clean through the entire process, and you have any point of potential contamination over time, that water that's sitting on the shelf for that beverage you made is going to grow some sort of mold or culture on the inside of it.
Yeah. If it doesn't have any alcohol in it, you're right. You're right on the money. Or if it doesn't have like preservative or whatever. The other thing would be kind of interesting, you put it into a can, right? Or you put it into a beverage of some sort. It's the glucose, since it's hydrophilic on the outside, it's not going to be very soluble, or it's not going to really stick very well to the can liner, which is hydrophobic, right?
Right.
As opposed to a liposome.
Right, or it's going to cake.
Yeah, it's going to cake, or it's going to go there. It's going to see the liner. It's going to say, I love the liner. It's hydrophobic. I'm just like him, or I'm just going to go, and then they stick together. So that would be, kind of the major differences. Of course, you have to test all this stuff, right? Yeah, I would say that the other thing could be particle size and particle size distribution, but I think you still need to filter if you want to have something really super uniform.
Right.
So that would be something to think about. I think process is totally different also. You have the need to do, mixing under high pressure with CO2, so you have to have that right equipment. But sure, it takes care of the water aspect. I think water is just, generally evil from the standpoint of trying to maintain it, get rid of it. Once you have it, it's really hard to do. So a lot of people spray dry, actually. They'll take that complex, like the liposome complex, and they'll spray dry it, right?
Spray dry it, or there's certain formulations of the liposomes where it will dry over time, or in a vacuum oven fairly quickly.
Right.
But spray drying tends to be the first go-to, because it's the easiest.
Yeah, and it'll maintain the stability of it, and it'll also prevent agglomeration and things like that. So, yeah, it'd be kind of interesting. I mean, that's what's nice about it. It comes out as a pure white powder with no water, and then you can put it into whatever water you want. So it's stable right out of the bat, and you don't have any solvent to deal with, which is really nice. One of the limitations, I think, of the inclusion complex using the specific method of CO2 would be the solubility of the actual material in the CO2. It's very amenable for any type of like nonpolar type of API or nonpolar. You can also probably encapsulate a liposome. That would be another thing you could do, and I think that's done quite extensively. I know that cyclodextrins have been used in food. They've been used in like topical formulations and things like that. So as long as the requirements aren't really stringent, you can use them in consumer products. And I think that there are also requirements for making sure that you don't have the liposomal material is also not toxic, right, for the particular application and use. Yeah. Those would be a couple different things. You can see there's radical difference in the process. Definitely.
Tremendous. One-step process versus a 4 or 5 step process, right?
Yeah, right.
Crucial.
You could do also, inclusion type complexes in water and then spray dry them in the same way. But if you didn't have to do that and you could do it in CO2, it'd be much, much better.
Much better. I like it easy. I like to keep it easy if we can.
Yeah, it's super easy. So, all right. Well, anyway, any other thoughts on that?
No, I think it's definitely a newer technology that's kind of hitting in the cannabis world.
Yeah.
Is using the inclusion method.
Yeah.
I think it's something that should be looked out for.
Yeah.
It can change a lot of people's game, a lot of people's companies.
Right. Yeah. So if you want to explore that with your particular company, give us a buzz. We do that type of equipment. And we have done those types of inclusion complexes, and they're pretty cool. I think there's going to be a lot of advancement along those lines. The liposomes are starting to get kind of flashy, but they've been around forever. But again, they got a lot of, like some of them are natural, but some of them are just not natural, right? So you got all those chemicals. I'm kind of an anti-chemical guy. Yeah. I'm an anti-chemical chemist. All right. Well, you guys have a good day, and we'll talk to you later. Stay tuned.
Take care.